55 Cancri A. 55 Cancri A is a super-Earth exoplanet located roughly 40 light-years from Earth in the Milky Way galaxy, situated within the constellation Cancer, and it orbits a sun-like star known as 55 Cancri A. The planet follows an extremely tight orbit, completing a full revolution in only 18 hours, which places it extraordinarily close to its host star and exposes it to intense stellar radiation. As a result of this proximity, surface temperatures are estimated to exceed 2,400 degrees Celsius, making the planet far hotter than any naturally occurring environment on Earth and hot enough to melt rock. Scientists therefore believe that large portions of the surface may be covered by vast oceans of molten lava rather than solid land. What makes 55 Cancri AE particularly unique is its carbon-rich composition, which sharply contrasts with Earth's oxygen-rich makeup dominated by silicate rocks. This planet likely formed in a region where carbon was more abundant than oxygen, allowing carbon to play a major role in its internal structure. Under the immense pressures within the planet, carbon may crystallize into diamond, especially within the mantle and possibly the core, meaning a substantial portion of the interior could consist of diamond and graphite instead of iron and silicate rock. No moons have been detected orbiting 55 Cancri E, and its extremely close orbit and strong gravitational interactions with its star make the long-term stability of moons highly unlikely. Human survival on this planet is completely impossible due to the absence of liquid water, lack of a breathable atmosphere, extreme radiation, crushing pressure, and intense heat, conditions so severe that even robotic landers would be unable to survive on the surface. Compared to Earth, 55 Cancri A is far denser, dramatically hotter, and chemically alien, while compared to the Sun, it is extremely small and insignificant in scale. Yet despite its hostility, it remains one of the most closely studied exoplanets and the strongest known candidate for a diamond-rich world. WASP-12b. WASP-12b is a hot Jupiter exoplanet located approximately 870 light-years from Earth in the Milky Way galaxy, within the constellation Auriga, and it orbits its parent star at an extraordinarily close distance. The planet completes a full orbit in just 1.1 Earth days, placing it so near to its star that it is subjected to overwhelming levels of radiation, driving atmospheric temperatures beyond 2,500 degrees Celsius. Unlike Earth, WASP-12b is a gas giant with no solid surface, consisting mainly of hydrogen and helium, yet it stands out scientifically because of its unusually high carbon-to-oxygen ratio. This imbalance indicates that carbon-based compounds dominate both its atmospheric composition and internal chemistry, setting it apart from planets formed under more oxygen-rich conditions. Deep within the planet, where pressures reach extreme levels, carbon may be compressed into diamond structures, potentially leading to diamond rain that sinks toward the core. WASP-12b's proximity to its star is so extreme that its atmosphere is actively being stripped away by stellar radiation and gravitational forces, producing a long, comet-like tail of gas trailing behind the planet in space, a phenomenon known as atmospheric escape and one of the most dramatic examples ever observed. No moons have been detected orbiting WASP-12b, and the intense tidal forces and unstable gravitational environment make the long-term existence of moons highly unlikely. Human survival on WASP-12b is completely impossible due to the absence of solid ground, lethal temperatures, extreme gravity, and radiation levels far exceeding human tolerance. Compared to Earth, WASP-12b is vastly larger, far hotter, and entirely gaseous, while compared to the Sun it remains a planet, albeit one that is gradually being eroded and destroyed by the powerful forces of its host star. The planet is scientifically significant because it reveals how radically different planetary chemistry can be from Earth's, and provides insight into how diamonds may form in environments entirely unlike those found in our solar system. Gliese 436b. Gliese 436b is an exoplanet located about 33 light-years away from Earth within the Milky Way galaxy, where it orbits a red dwarf star that is much smaller and less energetic than the Sun. The planet is classified as a warm Neptune because it is comparable in size to Neptune, but experiences significantly higher temperatures as a result of its extremely close orbit, completing one full revolution around its star every 2.6 Earth days. One of the most remarkable features of Gliese 436b is its proposed internal structure, which scientists believe contains enormous quantities of hot ice, a form of water compressed under such intense pressure that it remains solid even at temperatures above 1000 degrees Celsius. Beneath this superheated ice layer, methane is thought to decompose due to extreme pressure, releasing carbon that may crystallize into diamonds and gradually sink toward the planet's core. The planet's atmosphere is dominated by hydrogen and helium, with smaller amounts of methane and carbon monoxide, creating an environment entirely unsuitable for life. No moons have been observed around Gliese 436b, likely because powerful tidal forces from the nearby star prevent stable moon formation. Its gravitational pull is far stronger than that of Earth, and there is no breathable atmosphere or surface liquid water present. Human survival would be completely impossible due to crushing pressure, the absence of oxygen, and hostile thermal conditions. When compared to Earth, Gliese 436b is substantially larger and chemically alien, while in comparison to the Sun, its host star is relatively small and faint. The planet's scientific importance lies in its support for theories suggesting diamond formation inside icy planets, reinforcing the idea that diamonds could be widespread throughout the universe under suitable physical conditions. HD 189733b HD 189733b is an exoplanet located approximately 64 light-years from Earth within the Milky Way galaxy and is classified as a hot Jupiter due to its large size and extremely close orbit around its parent star. The planet completes one orbit every 2.2 Earth days, placing it so near to its star that it is exposed to intense heat and powerful radiation. Its striking deep blue color is not the result of oceans, but is instead caused by silicate particles suspended in its atmosphere, which scatter blue light. HD 189733b is particularly well known for its extraordinarily violent weather conditions, with wind speeds believed to exceed 8,000 kilometers per hour and temperatures so extreme that rock can vaporize. Scientists theorize that under these harsh atmospheric conditions, silicate materials condense into glass particles that fall through the atmosphere as sideways glass rain driven by the powerful winds. Beneath the turbulent atmosphere, immense pressure may act on carbon-based compounds, potentially causing them to compress and form diamonds deep within the planet's interior. No moons have been detected orbiting HD 189733b, and as with other hot Jupiters, the intense gravitational and tidal forces make the long-term stability of moons highly unlikely. The planet has no solid surface and offers no environment capable of supporting life, making human survival completely impossible. Compared to Earth, HD 189733b is vastly larger, far more massive, and infinitely more hostile, while in relation to the Sun, it remains a planet whose structure and behavior are strongly shaped by overwhelming stellar radiation. Its scientific importance lies in demonstrating extreme atmospheric physics and providing insight into how diamond formation may occur far below observable planetary layers. Kepler 13b is an ultra-hot Jupiter located approximately 1,730 light-years away from Earth within the Milky Way galaxy, orbiting a massive and extremely bright star at an extraordinarily close distance. It completes a full orbit every 1.76 Earth days, a proximity that exposes the planet to intense stellar radiation and results in surface temperatures exceeding 3,000 degrees Celsius, making it hotter than some small stars. Under such extreme thermal conditions, ordinary molecules cannot remain stable, causing atmospheric compounds to break apart while the upper layers of the atmosphere become electrically charged. Carbon-based molecules are destroyed in these upper regions, yet scientists theorize that far beneath the visible atmosphere, where pressures are immense, carbon may be forced into crystalline diamond structures deep within the planet's interior. Kepler 13b also exhibits one of the strongest known temperature contrasts between its day and night sides, a result of inefficient heat circulation that prevents energy from being evenly distributed around the planet. No moons have been detected orbiting Kepler 13b, and the powerful tidal forces generated by its close orbit make the long-term existence of moons highly unlikely. Human survival is entirely impossible due to extreme heat, intense radiation, the absence of a solid surface, and the planet's overall hostility. Compared to Earth, Kepler 13b represents an unimaginably extreme environment. While compared to the Sun, it is cooler but still ranks among the hottest planets ever discovered. Its scientific importance lies in helping researchers explore the upper limits of planetary endurance and understand the exotic states that matter can reach under the most extreme conditions found in the universe.